Hi, welcome to my channel. In this video, we will learn about n queen problem. What we will mainly do here in this video is see what the problem is. Then we will study about why is it difficult to solve it manually. Then we will create a simple algorithm based on our way of solving it. And then we will implement this algorithm and solve the problem. So this is the aim of this video. So let's get right into it. Okay, the first part, what is an queen problem? It is stated as a problem where we need to place n queens on an n by n chessboard so that no two queens are attacking each other. Now to get a good idea about what this problem is, we will consider a specific version of this problem, and that is where n is equal to 8. Therefore it becomes 8 queen problem, and the definition of this problem then becomes, or the objective of this problem becomes, to place 8 queens on an 8 by 8 chessboard such that no two queens are attacking each other. Yeah, we took n is equal to 8 because the standard chessboard is 8 by 8 chessboard. So let me draw a chessboard and then try to solve this. So this is our chessboard. I'm not gonna make the squares black and white because that is irrelevant for understanding the problem. And also one more thing that is important to know is that in chess, when we place a queen, let's say I place this queen here, what that means is that this is attacking any piece in the same row. So all these squares are being attacked by this queen. Also any square in the same column and the diagonals. So all of these squares are also unsafe to place any other piece, otherwise it would be captured by the queen. So these squares are attacked by this queen. Now knowing this, let's try to place 8 queens on this chessboard. Let's say we place the first queen on the top left square, which means now all the squares in the same row are being attacked. So we can't place any queen here. So we can't place any queen in any of the squares in the same column and in this diagonal. So all of these squares are now attacked by this queen. But still we have many squares left, so we can place the next queen here. Now more squares are being attacked, and then let's continue this process a bit further to place the third queen. And now the fourth one, the fifth one, sixth one, and now we're left with only one square to place the seventh queen, but we can't place eighth queen here. So okay, it's not a very straightforward problem to solve. Also, if you look at the number of combinations that we would have to evaluate are very high. So to place the first queen, we have 64 different possibilities because there are 64 squares on the chessboard. And when we have placed that queen, to place the second one, we have about 42. When we place it in the top left corner or any of the corners, we still have 42 squares which are not attacked or occupied, and that's where we can place the second queen. But when the second queen is placed, to place the third queen, we still have 22 squares and so on. So the total number on an average is millions. So basically, we have to try all of millions of combinations to find out all possible solutions. What we will do is we will write an algorithm which we can then implement. Now let's try to create an algorithm based on the method that we tried. So what we will do is we will create a function called as place queens. This function will take two parameters, n, the number of queens, and second one is actually the chessboard, which we can call as squares. This will be a two-dimensional array which represents the chessboard or each square. So in this function, then what we will do is first, because what we do when we are trying a solution, we first place a queen here, then we mark all the squares which are being attacked by it. So all of these squares, all the squares in the same row, same column, and which are um, the diagonal. Then among the remaining squares, we try to place seven more queens, right? So we place the next one here or somewhere else, and then we repeat the same thing about marking the attacked squares, and then we again repeat the same process with the remaining unattacked and unoccupied squares by placing the remaining queens. Say we have tried this combination of placing all the queens in the remaining boxes, and we have done that for, we have placed the first queen here, and then we tried to place other queens in the remaining squares. Then we can try to place the first queen here and then try all combinations. Similarly, we can continue with each of these squares by putting the first queen there. So these are all possible ways in which we can place the first queen. So what we are doing is actually for every row and for every column or for every square, we are trying to place the first queen and then trying to place the remaining queens in the unoccupied, unattacked squares. So what we do here is for every row, and let's call it I, we will repeat a certain procedure. Similarly, for every column, let's call it J, we will repeat a certain procedure. That will be if squares IJ is unoccupied and unattacked. So if this is the case, then place queen at squares IJ, and then we will not only place the queen there, but we will do something more. So we will place the queen at that, then we will mark the attacked squares, then we will repeat the same process for the remaining squares. So what we will do, we will call the same function place queens, but this time we will pass n minus 1 as parameter and then squares, which is now updated with the attacked squares, and this way we will recursively call the same function. So okay, this is what we will do, and then we will be done. Now we need to take care of one more condition here, and that is when is the problem solved. The problem is solved when you have placed the last queen. So basically we need to make some room here to check that condition. So I'll erase this part, I'll also erase these things, and that is if n is equal to 1, that means one queen needs to be placed, and when we have placed that queen, then the problem is solved. So say when n is equal to 1, then we have a solution, and if n is not equal to 1, well, then we just have to continue the process. So else place queens n minus 1 and squares. And there you have it. So this is our algorithm for solving this. And this is a very simple algorithm in the way that we just tried it. This if ends here, this if ends here, this for loop ends here, this for loop ends here, and the function ends here. So this is our algorithm. What we will do is we will implement this and then we will test that it works. And we should also have a solution which we can then verify. So this is the implementation of the algorithm that we just saw. The source code is available on GitHub and the link to that is in the description. So you can get it easily. I will explain this briefly. I will not go into too much detail. So if you have any questions, you can put it in the comment. I will try to answer them. And if needed, I can make a video dedicated to this solution, but I think it should be easy to understand. So the implementation is in this class nqueen problem all solutions, and the function that corresponds to the implementation of the algorithm is this place queens. So as we can see, this function, or as it is called in Java, this method takes n, the number of queens to be placed, as the first parameter. Then it takes squares, which represents the chessboard, the two-dimensional square array, and it takes an extra parameter solution, which was not present in the algorithm. This is needed because in the algorithm we just say we found a solution when we have found a solution, but here we actually want to print the solution, and therefore we are using this parameter which keeps track of the solution which is found so far. Okay, so that's why we need this. Now, as you can see here in these comments, the entire algorithm as we created has been written, and beneath each comment the implementation of it is present. What I would also want to highlight at this point is that this implementation or this algorithm is brute force algorithm because it takes into consideration all possible combinations and it checks which ones satisfy the criteria or which one is the solution. This is not the most optimal solution. There are many ways to solve nqueen problem and which are quite optimized than this one. Okay, so start with the first line. For each row I, this is simple for loop which is corresponding to each row. Similarly for each column j, so this is a for loop that corresponds to each column j. So that way you get squares ij as each square. So the next line, if squares ij is unoccupied and unattacked. Now we do that by writing this if condition, which checks if there is a queen or if the square is not attacked. If that is the case, then we place queen at that square and mark the attacked squares. And that is happening here in this call. So place queen is another method which places the queen at squares ij, and it also marks the attacked squares. Now you can look at the implementation and then you will figure that out. Also, there are a few more lines which are written. So basically, this is just getting the coordinates of squares I comma j. We are also creating a copy of this squares variable. For that, we have written this copy function. What it does is it just basically creates a copy of this two-dimensional array. And we need this because the way Java works, when you call another method from this method, it actually passes the same object to that, and then that object can get modified in the call method. Now, we don't want that here. We want each method to have its own copy of this squares variable, and therefore we create a copy here, and then we pass that copy to the placeQueen function. We also put these coordinates in the solution because once you put a queen at a particular location, then that becomes part of your solution. So we add it to the solution. Then the next line, if n is equal to 1, then solution found. So if n is equal to 1, then what we do is we print the solution that we have found. And we also call this method add to solutions, where we pass the copy of the solution as well. So basically, when you find a solution, we could find the same solution again because you might come up with that same combination of queens by putting them in a different order. And this method here, it makes sure that we only have unique solutions. Otherwise, we would get like enormous number of solutions. So we are interested only in the unique solutions. That's why this function or this method is created. Else place n minus 1 queens, and that we do that by calling the same function place queens and passing it n minus 1 copy of the squares and the solution that we have created so far. And there is one more line, solution.remove quads. Why is this line added? If you look at this implementation, in each iteration, we place the queen at squares ij and then try all possibilities to solve the problem. When we have tried all possibilities, then we move on to the next iteration where we move the queen to the next square. And therefore, the previous square is not part of the solution anymore. And that's why we have to remove this quads from the solution. That's the implementation. I mean, it looks exactly same as the algorithm that we created with some extra lines that are specific for this implementation because we are doing it in Java. So now that we have seen this solution at a pretty high level, we can just run this and see that it will give us the solutions to n queen problem. Also, another thing to note here is that we are passing 8 here. This solution would work for any number of queens, but we are passing 8 here, which means this is a solution to 8 queen problem. So let's run this. And as you can see here, it is actually printing all the solutions that it has found so far. And this takes a little bit of time. On my machine, it takes 1 minute to complete this whole search. And it prints every solution. And at the end, it prints the unique solutions. Also, another thing to note is that if you increase this number here, it will take even longer. Just make sure, I mean, you give it enough time or not to have this number very high. Otherwise, the program will keep on running. And if you want to find out solutions to n queen problem where n is a really high number, then you should use optimized versions and not the brute force algorithm. Okay, so the program has run and it has found all solutions. As you can see here, that it has found a lot of them. Also at the bottom are the unique combinations, and therefore these are the solutions that we are interested in. And there are also quite a lot of them. What I will do now is I'll just randomly pick one solution and then verify that this is indeed a solution to an 8 queen problem. So let me select this one and see that this is actually a solution to the 8 queen problem. Okay, so what we have here is the solution that we selected and a chessboard with the row and column numbers written next to it. Now let's verify if this is indeed a solution to the 8 queen problem. So the first coordinate is 0, 1, 0th row and first column. Let's put a queen there. Second coordinates are 1, 4, 1, 4. Let's put a queen there. 2, 6, 3, 0, 4, 2, 5, 7, 6, 5, 7, 3. Okay, so we have placed all 8 queens, and now let's see if they are attacking each other. So this queen would attack all of them in this row. Well, there aren't any in this row. Also in this column, there are none. Let's get the diagonals. Okay, so others are safe. Now let's look at the second queen. None in the row, none in the column, and now the diagonals. Also pretty safe. Third one, row, column, diagonals. Okay, fourth one, row, column, diagonals. Oh, fifth one, row, column, diagonals. Sixth one, row, column. Seventh one, I don't see any in the row, nothing in the column. Diagonals are also safe. The row is safe. Column is also safe. Diagonals are also safe. So as we can see, we have now found all solutions for 8 queen problem this way, and by running for different values of n, you can find solutions for, well, any n queen problem that you want. So that's all for this video. Thanks for watching. If you like it, do click like and consider subscribing for more such content. Thanks for watching, and I'll see you in the next video.